All right, thank you. All right, fantastic. Well, hello, everyone, and welcome to the intersection of architecture and implementation. I want to start this talk with a little story. So a business sponsor says, we need an architecture that will support 500,000 users concurrently with an average response time of 600 milliseconds under load. And the architect says, no problem, I'm on it. And the architect develops, creates an architecture. So the architect brings that architecture to the development teams and says, here's the new architecture. Well, you can guess. The development team has a few questions. First question, well, for all of the asynchronous communication that we have, should we use topics or should we use streams, like in Kafka? What do you suppose the answer is from the architect? Oh, no, it's not. It depends. You see, there are two very famous continual quotes from architects. You're right. The first one is, it depends. And you know what the second one is? That's an implementation detail. Yeah. But what about the persistence framework? What should we use there? Again, that's an implementation detail. Look, my job is architecture. Your job is implementation. Now get to it. And of course, the developers implement the architecture. And what do you suppose happens once we hit about 1,000 users? Errors, exactly. And after about 2,000 users, the whole system just comes up in flames.
I think you're going to need this for the rest of your talk, so I'll leave that here, okay?
Thank you, yes. There we go. I better put this somewhere because we will be using a lot of it, yes. This is frustrating. This is an all too common situation where we try to do the right things, but it doesn't work. Why? Turns out, most of these cases are because the architecture is not lined up and aligned with the implementation and vice versa. And that's exactly what I want to show you in this session. I want to talk about the intersection of architecture and implementation, where they intersect, but also where they diverge, because they do. So I'm going to talk about some of these problems, but then I'm going to show you some techniques and tools you can use to realign and bring architecture and implementation back together. In our journey, we'll be looking at three roads we're going to travel on. The first road of alignment will be that of operational alignment. The second road on our journey will be that of structural alignment between the architecture and implementation. The third road will be about constraints that we place on the architecture, which also is a form of alignment. So we're going to take a look at all three of these and then see how to fix some of these problems. Well, let's put some stop signs on our structural and constraint, and let's take a journey down that operational road to see how this alignment works, well, or doesn't work. So when we talk about operational alignment, I'm talking about those operational kind of characteristics. As the system or product or application is running, does it scale? Is it reliable? Is it responsive? All of those kind of operational characteristics. So here's another scenario. Well, in this new system, we're expecting anywhere from thousands to upwards to 500,000 concurrent users. So what does the architect do? Well, the architect goes to our star rating chart that we developed in Neil and I's book, The Fundamentals of Software Architecture, and does some qualitative analysis, comparing the quality of one thing to the quality of another. which architecture would be suitable for this kind of problem? Well, 1 star is really bad. 5 stars is really good. Well, our concerns with this kind of problem are all about scalability and elasticity. And if we take a look, we indeed do have some architectures that rate 5 stars for these, microservices being one, and space-based architecture being another. Well, due to kind of the shape of the problem and some of the complexities with space-based, the architect chooses to use microservices. And architecturally, this is a really good choice because it will satisfy those requirements of thousands to 500,000 users, that kind of elasticity, because not only of the bounded context, but because of the short, in terms of hundreds of milliseconds, of mean time to start with each individual service. Yeah, this architecture will work, and it's a good choice. Now, let's go to development. So we have an order placement service where a customer can go and place an order to create an order. But the development team realizes because of these bounded contexts in microservices, that order placement service is going to have to go make a call over to the inventory service, retrieve the inventory, and send that inventory back to that order placement service. Development team looks at this, and they're sharp, by the way, and say, this is way too slow, and it's coupling these services together. This is a problem. I know. To better decouple these services, what we can do is put an in-memory replicated cache in inventory, and then have a corresponding read-only replica in our order placement. And the team says, and we'll use Hazelcast to always keep these in sync, so that when we do have an update to inventory, now the cache gets updated in inventory, Hazelcast synchronizes it. Wow, this is cool. This is a smart choice because it is a lot faster. We increase our responsiveness, and we've decoupled our services. Development team give each other a high five and go ahead and implement this solution. After production release, what happens? Well, it works fine until we start to scale and we realize that that in-memory cache in each instance is 500 megabytes of items and their inventory. And as we start to scale, 2,000, 3,000 users, 10,000 users, we can start to see we will never, ever reach close to 500,000 users. Yet again, another epic failure. Whoop. There we go. Yes. What happened? These were 2 really good choices between the architect choosing the appropriate architecture and the development teams realizing inefficiencies. What happened was a misalignment where the architecture was focused on scalability and elasticity, but implementation placed more of a focus on performance and decoupling, thereby misaligning the architecture and those, quote, are you ready? Implementation details. Yeah, right. So this is the concern with operational characteristics and operational alignment. But there's 2 other kinds of alignment we have. Let's put a stop sign on the operational and open the road and take a journey through structural alignment. Let's take a look, for example, at a typical house or a flat or apartment. It consists of rooms. As a matter of fact, we can say that house is made up of rooms. Those rooms each serve a different purpose. We have a kitchen, different kinds of bedrooms. We have an office, a bathroom, all these kind of hallway, stairs. So you can kind of think of these rooms as the building blocks of that house. Well, by the same token, logical components, things that a system does, become the building blocks of our systems. Portions of the system, things that that system has tasks for, has to do. And as a matter of fact, those building blocks all form together just like that floor plan for the application. Or maybe it's services that they combine into. Either way, logical components are the building blocks of any software solution. This is what I mean by structure, by the internal architecture of a particular monolithic application or even a service. So let's take a look a little bit at this structure piece. This is called a logical architecture. And as a matter of fact, we couple or combine some of these components together into domains. We could actually see the architecture. We realize that logical architecture through the way we structure our code. So these logical components, the building blocks, they're just not boxes on a page. No, they're actually manifested through the directory structure or namespace of our systems. So for example, the higher level nodes represent the domains and subdomains of our system. And then the lower level nodes represent those architectural components, those building blocks of our system. So let me show you an example. Let's take payment processing, for example. Well, I need to write a class, so I will write a class, and notice it's getting placed right in that payment directory called creditcard.java, and this charges a credit card. When we write software, when we write class files, we physically have to put them somewhere. So this one goes inside the payment directory or payment namespace. Why? Well, Mark, it has to do with payment processing. But remember, a logical component in an architecture is manifested or realized through the namespace or package structure or directory, which means that that class file is one of the many classes that implements the payment logical architecture component. So that's our definition. Now, let's see how disastrous this could get. So here's our scenario in this case. Company needs a new system for their customers to be able to enter trouble tickets into the system for products that they buy from our company. If they have a problem with it for installation or the thing just breaks, they can enter a trouble ticket, and our field experts will come to your home or office and fix your problem. Well, as an architect, this is the logical architecture. Now, this is void of any databases or services. This is the logical architecture, how the system will be constructed. And you'll notice there's things like ticket creation, assigning a ticket, ticket assignment, ticket routing to route it to the field expert. There's customer profile, registration, surveys to send and receive them. All of these are the building blocks of that system. The logical architecture of a system shows how that system will work and how it's coupled, the dependencies between these pieces of functionality. Okay? So an architect spends a lot of time drawing lines and boxes and realizing, how is this going to work? Now we go to development. So the developers code this up. By the way, good news, 100% code coverage. Absolutely everything works. And this is what the development team came up with. Do we remember The logical architecture of any system can be realized through the way the source code is organized. Well, here's my logical architecture, but where is ticket creation? I can't find it in the source code. How about things like, for example, the customer registration or even the customer profile? I don't see it there. And this ticket state, that's not even in my architecture. Well, all that work that I did to draw and realize a logical architecture, a structure of the system, is not there. This is what that logical architecture looks like. And as a matter of fact, we can compare these two because the structure, the architecture of a system allows us to have better understanding of how it works, learnability, maintainability, the ease of testing of our system, the risk of deployment in our system. How easy is it to change, to understand the system, extend the system, adopt it to new functionality? Which of these looks a little closer to all of those goals? The original one. But of course, even though all the functional tests pass, this system is not maintainable, not reliable, not testable. No one understands it. It's just a bunch of lines. So here we see another type of alignment between architecture and implementation. The fact that the logical architecture and the way the code was structured didn't match. Okay. There's one more road to go through, and that is the constraints road. So let's move that stop sign over to the structural and go down this road of constraints. Yet another type of alignment between architecture and implementation. When we talk about constraints, let me show you an example. Here's another business case. We have a very tight time frame and a very tight budget for this new project. No one's ever heard that before. However, we also expect a lot of continuous change of the data structures in this system. We anticipate it. We know what's going to happen. We don't have a good understanding of this particular domain. And when we make those database changes, we have to move and make those as fast as possible. There's our problem domain. So the architect goes back to those star rating charts and says, I wonder what architecture would satisfy that kind of shape of a problem. And so key point is tight time frame and tight budget lend itself towards cost and simplicity. Now, here this might look confusing because a lot of stars mean really good. The fewer stars means really bad. So cost here is 5 stars. That does not mean it's expensive. That means it's really good. And we can see a lot of choices here. The traditional n-tiered layered architecture, that might be a possibility. Modular monolith, ooh, that's popular. Maybe we should use that. Microkernel architecture, otherwise known as the plugin, ooh, maybe I should put that in my wish list. But also, there's service-based architecture. Not as many stars, but has some. Wait a minute. Do you remember our problem? We're anticipating and will experience a lot of changes to the structure of that data. That's changes not to a domain. That's changes to a technical layer in the architecture. Architectures are partitioned either technically or by domain partitioning. But if we have a lot of changes to our data, wouldn't it make sense to have a technically partitioned architecture? And as a matter of fact, it would. 1 star for domain means it's technical. And so that kind of says, well, I think the layered architecture is the way to go. And as a matter of fact, it would be the right choice for this kind of problem. I mean, think about it. We've got a separation of concerns, technically, and also layers of isolation. Those two things combined in a layered architecture give us great change control. Because done correctly, those constant changes to the database means I'm only changing one layer in that architecture. All the other ones are good. Interesting. The layered architecture, which we've been doing for 70 decades, is not dead. No, this is a viable option. As a matter of fact, it's a really good architecture for this particular domain problem. However, to make this work, what do I need to do? I need to apply constraints. Our first constraint, presentation, business, and services, you can't talk directly to the database. You have to kind of go through all those layers. That's our first constraint. Second constraint, you have to respect the open and closed layers. Now, a closed layer means, I got to go right through that. An open one means I can bypass it. And the third constraint is this. All database logic must exist in the persistence layer. 3 constraints. You know, I would hire this architect. I would work beside this architect, because this will work. Let's take a look at the, quote, implementation detail. Because the presentation developers realize that this is nonsense. A lot of our queries just need simple data. I have to go through every one of these closed layers. This is silly. One of the members on this team realized that there's a pattern called the fast lane reader pattern. We can shortcut those layers and go to the database directly, therefore significantly increasing the performance and responsiveness of our system. Yeah, cool stuff. Let's do it. The backend developers get really frustrated about the fact that all the database logic is moved from the business logic. I mean, one of the trends that we have in this industry is, of course, to try to bring data closer to the processing, not further away. And this is making it a real hassle to maintain anything. It's taking too long. So the backend developers realize, it just makes a lot more sense, and it is a trend, to keep that database logic close to me so I could see everything at once. Much better maintainability. So they implement it that way. And of course, let's do our production release. Boy, don't you hate releasing software? Better get ready, because you know what's going to happen. All of a sudden, what? Well, that database change, sure enough, comes about all the time. But because the constraints weren't followed, I have to change every single layer in this architecture. And yeah, you know what happens. Yeah, disaster. Yes. Database changes take way too long. That was our primary goal. So what happened here in this scenario? Scenario was the architecture, very sound, focused on isolation of technical layers, agility, that ability to respond quickly to change. Whereas the implementation of this architecture placed more focus on maintenance and performance. Again, misaligned with the architecture. Wow, a lot of fires in this talk, isn't it? All right. Well, now we see the problem. There are 3 types of alignment that we continuously get misaligned. So how do we solve this problem? One way to do it is through governance. Governance, or compliance, done through architectural fitness functions. A fitness function in architecture is a test. It's something we write, or metrics we gather, that tests some sort of architectural characteristic objectively, meaning through metrics. These are tests that we can run to govern all three of these problems: operational, structural, and constraints. Well, let's take a look at how to apply governance, fitness functions, to our problem. Let's start with operational, where we started before. We have a lot of tools and metrics, or tools, I should say, that generate all sorts of metrics for us that we can start tracking and gathering for things like scalability, responsiveness, elasticity, reliability, error rates. We can leverage these tools, or sometimes we write them ourselves in production. And let me give you an example. Here's a website, a service, a system, a product. And what that does is it streams, it makes observable some sort of metric, let's say response times and user load, that we stream to, let's say, Kafka or a queue. We then write a capture service, which then receives all that raw data and maybe does some filtering on it, because we don't need every data point usually. Then the fun part comes, because then we write an analytics service. This is the fitness function that basically reads that data and starts tracking things over time, looks for trends, looks for thresholds. And when a threshold is reached or a trend is noticed, alert me. Otherwise, just leave me alone. And this just continuously runs in production. Now, here's a good example. We needed high levels of scalability. So we measure our user load against response time. And notice, our response time is starting to vary a bit, but we have a consistent increase in the number of users. But look at our response time. This is what that analytics service does, that fitness function does. It calculates either the slope, for example, or maybe a standard deviation from a variance of a mean. And we can see that this is overall pretty flat. Yeah, this test demonstrates a scalable system. Or it would demonstrate that it isn't scalable. So these fitness functions are really useful for these kind of operational concerns. And isn't it interesting? Most of you have probably heard of fitness functions. I'm hoping a lot of you use fitness functions. We tend to think of these kind of tests only for operational stuff. But they can also be used not only to align operational characteristics and architecture with implementation, but also for other aspects. For example, let's take a look again at our structural alignment, or the problems we had with that. What we can do to leverage these are free tools that are available. In Java, ArcUnit. In .NET, ArcUnit Net, NetArc Test, SonarGraph for Python, C++, Java, C#, PyArc Test for Python. These are all tools that are available to you here that you could actually write tests to govern the structure of our system, that logical architecture. Let me give you a very simple example. We want to have that directory structure represent our logical architecture. But what's to stop a developer from naming it anything they wanted to, or creating more and more and more domains? This test stops them. Because this will fail if that directory structure becomes misaligned with our logical architecture, our components. Classes should reside in a package, A, B, C, or D. And we can continue to write these tests to basically codify our logical architecture. That's really cool. And of course, we can plug this into NUnit, JUnit, any kind of testing framework, or even just our pipeline. Neat. And this is one way of assuring this alignment between our logical architecture and the way our code is actually structured. Well, there was a third, wasn't there? And that was constraints. Let's take a look at constraints, because we can use these same tools that I just showed you to also govern constraints we have. So, presentation layer can't talk to the database, can't talk to persistence. You have to go through all of the layers. They're closed layers. Okay, that's a constraint, but no one's going to follow that. No one cares. So how do we write a test for it? Well, in ArcUnit, it's actually pretty simple. No classes that reside in a package presentation or persistence, or in this case presentation, should .access classes that reside in a package or namespace persistence. Check. Yeah, these are really cool tools. The same thing in C#, for example. Types in the current domain that reside in a particular namespace should not have a dependency on these. Now, Neil Ford and I have been experimenting. We use these all the time. And past couple of months ago, we were musing, hey, I wonder how generative AI would work for generating these kind of tests. If we can describe our constraint, describe our architecture, describe what we need, can it generate ArcUnit code, NetArc test code? Well, the good news is, yeah, it actually did a really good job at generating this stuff. Yeah, which now, okay, I'm sorry, you just simply don't have an excuse now to do this. I don't have time. It's a prompt. All right, so this is yet another way of aligning constraints. Another alignment between architecture and, quote, that implementation detail. That stuff works. Governance is really good. I mean, that's going to keep things aligned. But there's a problem. There's a big problem. Because the only thing governance shows us is that we have a problem. We're continually slapping developers' hands saying, don't do that, don't do this, don't do this. Yeah, governance is good. I would urge you to use these tools, use fitness functions, any of these tools to govern. But it's not going to solve the problem of alignment. Because the root problem is all about communication and collaboration. Let's face it, this is tough. Developing software is hard. Because we do have software architecture way over here. And we do have implementation way over there. And the problem is these are two separate things. I mean, a software architect has specific roles on any product. The first is to understand what are those architectural characteristics that are critical or important to us. What kind of architecture style matches those and the shape of our problem, and designing the internal structure, those logical components of the system. That's what an architect does. And then those artifacts get sent over to implementation. And what do developers do? Well, they take those components, like payment or order placement, and now they figure out what classes should I do. That's design. Class diagrams, figuring out inheritance, composition structures, and what patterns to use. Also, maybe it's UI design. And of course, coding. Well, this picture right here shows you exactly why we continually get out of alignment with architecture and implementation. Why things will never work. And it's because of this single unidirectional line right here. Everyone, there's really not a gray line, a gray area between architecture and design or architecture and implementation. No, we can get rid of that gray line. Because you know what it is? It's a chasm that separates these two camps. And as a matter of fact, most of the decisions an architect makes go straight into this canyon right here. Developers never, ever see them. Well, what do development teams do when they implement our architecture? What they do is they actually validate our assertions and assumptions about the problem, about the architecture. Oh yeah, and those are always correct. Yeah, so changes need to be made to the overall architecture and design. Development teams do that, and those changes go straight into that chasm, never reaching the poor, hapless architect who thinks that their solutions are perfect everywhere. Wow, no one says anything about it. It must be great. Oy. Listen, to get architecture to work, to realign architecture and implementation, that requires us to fill in this chasm and form a bi-directional relationship between architecture and also implementation, where the architects are on the same virtual team, allowing for very effective communication of changes and the architecture itself to the development team. And when, not if, we're wrong as the architect, those changes effectively get back to me so that I can change the architecture and get those changes effectively back to the development team. And as a matter of fact, this is one of the only ways I've found, everyone, to facilitate those soft skills of mentoring, coaching, and leadership that an architect is supposed to do with development teams. So how do we do this? I mean, we're told, yeah, we should communicate and collaborate. We're always told that, but we're never told how we should do it. Let me show you how. So there's two golden rules of collaboration between architects and development teams, engagement models. Here's the first one. If developers don't know why you made a decision, they're less likely to agree with it. Number two, if developers aren't involved in the architectural decisions, they're less likely to follow it. Oh, they might agree. Oh, I agree with you, but we're not going to do that. We're going to do our own thing. Yeah. Well, let's take a look at these two golden rules of collaboration and how to solve these issues or address these issues. Let's start with the first one. Golden rule number one, if developers don't know why you made a decision, they're less likely to agree with it. This leads to what Neil and I coined in our fundamentals book, the second law of software architecture. Why is more important than how. Oh, I could look at an architecture diagram and I could see how the system works, but what I don't know is why you chose to do it that way. Yes. So one of the ways to solve this problem, architecture decision records to the rescue, ADRs. Now, I want to pause right here because it used to be back in around 2018, 2019, the pre-pandemic days, we used to have a drinking game at conferences, and it was called the Conway's Law drinking game. Anytime anybody up on stage said the words Conway's Law, you had to take a drink. You wondered why all the speakers were stumbling around on stage? Yeah, because it was mentioned about every 5 minutes. Well, now, enter 2023, 2024, that drinking game has changed. Anytime a speaker mentions ADR, you got to take a drink. Yeah, and we still have a bunch of drunk people in the conference. But here's the thing. A lot of you may have heard of architecture decision records, maybe using them. But most of us think of those as grown, yet another form of documentation. Nope. I'm going to show you how to leverage an ADR as a tool for engagement as a tool for collaboration, not documentation. So when we make an architecture decision, we fill out an architecture decision record. Each decision has its own. I put the title, the status, whether it's proposed or accepted, maybe it's superseded by another one, a short paragraph, a couple of sentences about the context. What is it I'm having to make a decision on? The decision itself with justifications and the consequences of that decision, the impact. This is not documentation. This is a tool we could all use because we could leverage two sections here. First, the decision section. I have to provide a justification for my decision. And also the consequences. I can now describe the trade-off analysis and the impact and the consequences of this decision. This is a fantastic vehicle between architects and developers to solve this why problem. So this is just leveraging them. By the way, you're like, oh, wow, what a great idea, Mark, but our company doesn't use ADRs. Well, neither does ours. We still use them. You don't have to embrace the whole infrastructure of an architecture decision record. I call these temporal architecture decision records. In other words, we're not going to use them for documentation. No, I'm using these as a vehicle so that developers understand why I'm making certain choices. Okay. Let's take a look at that second golden rule here. If developers aren't involved in a decision, they're less likely to follow it. Here's the problem. Let's read this. So the architect says this: we're going to use request-reply messaging between our services because it's faster and it's more scalable than REST. Well, okay. Right away, we see a couple of problems with this statement. Oh, the good thing is that I did justify it. We're using it because it's faster and more scalable than REST. But this is not collaboration. This is communication. I'm telling the development team this. And what do you suppose a likely response would be? Yeah, actually, we're going to use REST. We checked with ChatGPT, and it says it's actually faster and more scalable. So, but wait a minute, says the architect. I'm the architect. This is my decision, and our environment is faster. Yeah, whatever. Hey! Wow. What do we do now? Yeah, talk about losing control of the team. The root cause of these kind of real-world scenarios is actually a matter of lack of trust and respect. If we had another 45 minutes, we would launch into that topic, but we only have a couple of minutes left. So, how do we address this problem? Well, let's address it. The answer is right here, DDD. But not domain-driven design. No, that will not solve this problem. What will is DDD. Remember those three letters. Demonstration defeats discussion. DDD. We could talk all day and argue all day about something and not get anywhere. If I can demonstrate for you with metrics, actual results, it usually stifles the argument and stops the discussion. Let's go back to that really bad scenario and look how to repair it. So the architect says this: hey, I ran some benchmarks in our production environment against REST and messaging. And take a look at this. This is really interesting. So in our environment, response times go north, and we've got, of course, user load. And watch this. When I ran these benchmarks in production, check it out. ChatGPT, close to right. I mean, yeah, it was just as scalable, just as responsive, but look what happens, because this is where our expected user load is. And this is our response time service level agreement. And you can see messaging is well within this range. But at these levels, in our environment, rest is not. So, based on this, says the architect, I'm thinking we should probably use request-reply messaging between the services. Are you ready? What do you think? That's collaboration. I'm not telling you, so based on this, we're going to use this. I think we should use this. What do you think? And now the response is, wow, well, we were going to use REST, but wow, based on this, yeah, well, you're right. I'm glad you did this. We'll definitely use messaging. And there's one last technique we can use to involve developers with our architecture and architecture decisions. You know what that is? Architecture decision records again to the rescue. A vehicle for engagement with the development team. So we can look at the status right here, proposed, accepted, superseded. Let's add another one. And that status is request for comment by a certain date, RFC status. This I'm opening up to say, development teams, pick it apart. What's your opinions? What's your criticism about it? And this allows developers to look at the decision before I make it and say, yeah, this is bad. Yeah, no, I don't like this. Oh, yeah, this is spot on, so on and so forth. This is a win-win situation. You can't lose by doing this. I win as an architect because developers feel involved in the decisions. It's not just me. I win as an architect because now there might be a comment in there of something I missed. I might have a comment about the fact you can't do that. There's a firewall between these. Oh, right. And therefore, together, we're making the right decision. These are all kind of techniques that we can use to basically realign architecture with implementation. So let me leave you all with this. This is one of my favorite quotes from our book, The Fundamentals of Software Architecture. And it goes as follows. Developers should never take the components designed by architects as the last word. Rather, it should be viewed as a first draft, where implementation will reveal more details and refinements. My favorite quote in our book. Collaboration, constant iterative architecture, working together with architecture and implementation to solve that business problem. Ladies and gentlemen, it is not an implementation detail. Awesome. Thank you all so much. Thank you. All right. I do believe we have some time for a couple of questions, if there are any from the crowd.
We do. Raise your hands.
Oh, the wonder ball goes round and round. I like that thing.
Hello? Hi.
Yeah.
Perfect. Amazing presentation, by the way. One question actually is, I've been hearing quite a lot, like in the a common point of talk is between how do you communicate stuff between architects and the dev teams, and that was a central point in your end of presentation. And then I propose a question: why do we still keep architects separated from developers in general? Why not empowering the development teams to take architectural decisions?
Yes, so fantastic question about this separation that we still continue to have, and development teams being able to empower them to make their own decisions, be more aware of architecture. One of the things that I evangelize perhaps the most in consulting gigs and trainings and conferences, master classes, is this notion of what's called architectural thinking. And this notion is about how do you actually think like an architect. This concept empowers development teams to be more aware of architecture And so by doing this kind of architectural thinking, we put less stress and less need on an architect, and we get much more effective and efficient software. For example, things such as knowing what are the architectural characteristics, those NFRs or non-functional requirements that we need, and constantly thinking about those as we're developing software. That keeps that alignment going, and I don't have to be the architect to say that. Things about trade-off analysis, understanding that how I make a decision is usually based on those architectural characteristics, scalability, responsiveness, agility, whatever they happen to be. And also, the third thing is increasing our technical breadth of knowledge. The amount of things I know less about, but more of. And it's that middle part of our knowledge triangle, things we know, we don't know. Those three techniques are one way of starting to really empower development teams to start thinking architecturally, putting themselves in the brain of an architect when trying to solve problems. So yeah. This is one of the things that I am evangelizing, and hopefully before I pass from this world into another one, more development teams will be embracing architectural concepts.
Do we have more questions?
One more question?
There's a hand going up in the back.
Oh boy. Here we go. Woo! I feel like I'm at the ball game again. All right.
Thanks so very much for the talk. It was interesting to hear you talk about architecture decision records, because whether or not we take a drink, I feel like a lot of the time there's a brief burst of enthusiasm, but the result is a lot of folders with exactly one architecture decision record in them, because you don't get the buy-in, and therefore people don't realize the value. So I wonder if you've got any kind of pointers on how to make it more of an ongoing process for communication rather than like an occasional, we must do this, and then it gets forgotten after a week.
Sure, absolutely, because I happen to be, as you probably guess, a big fan of ADRs. I find them extremely effective. However, most companies don't embrace them. Two reasons. One, a lot of times, to your point, it is all or nothing. You have ADRs that describe your architecture decisions and reasons why you did something, or you have documents. But if you start blending them, now I've got two places to go to figure out the architecture. And so it's that full immersion of them that usually leads most companies to say, yeah, not yet. So what I like to do to really demonstrate the effectiveness and power of architecture decision records are the same kind of techniques I just showed you here. Use these as a communication and collaboration vehicle and tool between architects and developers, what we saw here, but also engagement models between architects and also the product team. Product teams making certain decisions we don't understand. We make decisions the product team doesn't understand. And using this as a vehicle allows us both to come together in a single document, artifact, to be able to understand each other and to be able to also validate those decisions. So by doing this, temporal, by the way, temporal meaning they're just temporary. Trying this out creates an awareness of the value of these ADRs. And hopefully by demonstrating that value, again, remember DDD, Demonstration Defeats Discussion Europe, DDD Europe, there we go. But by demonstrating that value and other people realizing it, might cause other teams to say, you know, for this new product, why don't we try ADRs? Maybe it's for major decisions first, not every decision. Organizing architecture decision records is a big challenge. And usually the response is, well, just store them in a Git repo along with the code. But the problem is, who has access to your source code repo? The developers, but hopefully no one else. So I do like storing them in Git, but I usually have a separate repo for these. My preference is in a wiki or some kind of live document. but it's really practicing them. It is not easy because you're not sure what scope you should make an ADR. I'm making a decision. Does that really require an ADR? This morning, Neil showed you a tool you all have now for deciding whether something's more architecture or more design. And he showed you 3 criteria. Is it strategic in nature or not? What's the level of effort? What are the significant trade-offs? Things that are in that A-B range that he showed you, write an architecture decision record for. Ignore things in the C and D range of that spectrum. And these are some of the guidelines and ways of trying it out. It's not for everybody, but I find them extremely effective. So, yeah. All right. Fantastic.
I think we had one more hand up, and I think we have time. Did you have your hand up? Yes. Can you pass the cube to the front?
Okay, one more question here. Woo! Oh, wow!
One
All right.
throw, nice.
Draft pick right there. Draft pick number 1. Yes. Hey, you're on my team.
Yeah, my question's not going to top that. So yeah, I wanted to ask, with introducing ADRs in this format and introducing them as a dialogue, would you have any suggestions of would you follow the same pattern, which is demonstrate it before advocating for an ADR as we're going to do the ADR pattern that becomes like the pipeline dictatorial, or do you kind of use the same technique to go, hey, let's talk about this, and then afterwards you tell them what that was?
Sure. Well, do you remember the 2 things an architect always says? It's an implementation detail and...
It depends.
There you go. It depends. Sure, if I've got a fairly significant decision to make, I likely would. First of all, let me back up. I would use the same format. It's a good format. It's pretty solid. It has everything we need to communicate and collaborate and use it as a vehicle to go back and forth. So in fact, I would use that kind of format. However, regarding the demonstration piece, if it's a significant architecture decision that bears significant trade-offs, then I would probably, if possible, model it. Use qualitative analysis to demonstrate where I came up with something. These are things we can do within the decision section to justify the answers. With diagrams, pull up the star rating chart and say, because this has 5 stars and that has 1, we chose this. Yeah, okay. I'm not going to argue with that, and thank you for letting me know. So yeah, the more significant a decision, the more I would try to demonstrate that value before approaching it. Yeah, exactly. So wonderful. Hey, thank you all so much. It's a fantastic crowd, and thank you all. All right.
I'm happy you didn't actually burn the stage down.
That's true.